So thanks for the folks who joined the webinar today. This is our third webinar in the September webinar series. If you joined us last week, you would have heard Dr. Michael Rennie talking about microplastics in freshwater, and we had Dr. Laura Johnson who spoke about the reeutrophication of Lake Erie. If you want to check out last week's talks or even the talks from the first week, they're all posted on our website now. The same place where you would have registered or found the Zoom link for the conference. And for those of you who are local, you'll know that this webinar series is replacing our usual two-day in-person conference. And obviously we would have loved to see everyone in person this year, but I think we've made the best of a bad situation, and we've been able to invite speakers who we otherwise wouldn't have been able to hear from across Canada, and even two speakers in the series who are joining us from the States. So I hope that the topics and speakers are of interest, and that we can see everyone again in person maybe next year. So today we have two speakers. We have Dr. Kristin Bianchini, who is from Birds Canada and Acadia University, who's going to be talking to us about loons and lakes. And we have James Littley with the Okanagan Basin Water Board, who's going to be talking to us about milfoil. So the first talk is at 10, and then the second talk will follow directly after that, probably around 11 o'clock. Just for logistics, as viewers, you won't be able to turn on your cameras or your microphones, but the Q&A function is enabled. So as the presentations are happening, feel free to type your questions into the Q&A box. And at the end of the presentation, we'll help to facilitate those questions to the speaker. I'll also acknowledge our fellow panelists today. We have Jenna Curtis from Alberta Environment and Parks. Thanks, Jenna, for setting up the Zoom and all that fun stuff. And we have Caleb Sin from the Alberta Lake Management Society as well, helping out with facilitation today. Okay, so with the logistics out of the way, I'm excited to welcome Dr. Kristin Bianchini, as I said, from Birds Canada and Acadia University. And I think I'll just pass it over to you now.
Okay, cool. Just get my screen set up here. All right. Well, thank you to the Alberta Lakes Management Society for having me, and thanks to everybody who's tuned into this talk. Today I'm going to be talking about some interesting facts about loons, and then what loons are telling us about our environment. So first I want to share a bit of information about where I work. So I'm very fortunate to be able to work at Birds Canada because they do some really incredible research for bird conservation. So the mission of Birds Canada is to conserve wild birds through sound science, on-the-ground actions, innovative partnerships, public engagement, and science-based advocacy. And this is a picture of where I would normally work when it's not COVID time at their national headquarters in Port Rowan, Alberta. So Birds Canada programs fall into three broad categories. There's citizen science, research and conservation, and education. And it's the citizen science that Birds Canada is especially known for. So Birds Canada has over 35 citizen science programs that operate in every province and territory, and there are over 40,000 people participating in these programs annually. So this huge number of people can generate a massive amount of information to help bird conservation across the country. As for my work, I'm really lucky to be involved with the Canadian Lakes Loon Survey. It's one of the longest running and most popular citizen science programs with Birds Canada. And the first thing that I've learned since starting my work with the Canadian Lakes Loon Survey is that people love loons. So you can see this from just a quick Google search of loon logo, and it shows how popular loons are as a symbol. So they're on our money, they're on license plates, they're the symbols for different nature organizations, for sports teams, for outfitter stores. They're even symbols on coffee and beer. These are two brands that I highly recommend. And for some reason, they're also on kombucha, and they're the symbol for the Minnesota State Lottery. So it just shows how symbols of loons are pretty much found everywhere. So there's obviously something very special about loons that seems to strike a chord with just about everyone. And the quote that I'm showing here is by Arthur Cleveland Bent, and he was a famous North American ornithologist who was active during the early 1900s. And I think that it really gets at the heart of how people feel about loons. So he said, "Who has ever paddled the canoe or cast a fly or pitched a tent in the North Woods and has not stopped to listen to this wail of the wilderness? And what would the wilderness be without it?" So even as early as 1919, people considered loons symbols of northern lakes and of untouched wilderness. And as we'll see during this talk, choosing loons as a symbol was a really good choice because loons are also great indicators of the environment. So because loons are such great indicator species, they've been the subject of a lot of long-term monitoring studies. So for example, the loon that I'm showing here is a loon that was banded in Wisconsin as part of a monitoring study there. And I want to start my talk by discussing some really interesting aspects about loon natural history that these long-term monitoring studies have shown us. So it turns out that the natural history of loons is far more complicated and mysterious than we ever thought. So for instance, years ago, everyone thought that loons mated for life. So it is that the pairs that people saw in their favorite lakes were the same pairs that were returning every year. And loons were thought to be these peaceful, noble, and model bird citizens, so to speak. But it turns out that that was actually dead wrong. So loons actually switch partners quite often, and they sometimes get into these very violent fights over territories. Now, this doesn't happen a lot, but occasionally males will have these fierce territorial battles. They'll sometimes even fight to the death. And what's really crazy is that when one male dies, it's always the territory owner. It's never the incoming male. And this stuff was absolutely unknown before these monitoring studies started 25 years ago. So when these violent scuffles happen, 35% of the time the territory owner dies, but it's never the incoming male, always the territory owner. So what's going on here? Well, after males fledge, most of them migrate to coastal marine areas where they overwinter for several years. So most of the birds where I am in Ontario will go to the Atlantic Ocean, and then most of the birds in Alberta, Saskatchewan, and BC will go to the Pacific. After staying on the ocean, they return to their breeding grounds at about age 3. These 3-year-old males will then begin to try to acquire their first breeding territory. And there are 2 ways that males do this. The first way is by settling in an unoccupied area, where eventually an unattached female will hopefully join them. The males that follow this strategy typically get a territory by about age 6. Now, other males will wait a few more years to get their first territory, and they'll use a completely different strategy. So they actually become these vicious bullies, and they'll get their first breeding territory through what researchers call a hostile takeover. So they'll find a lake that's already occupied and oust the territory owning male by injuring or outright killing them. So this is pretty vicious and violent stuff. And these males don't just go around trying hostile takeovers at random. They'll prospect lakes beforehand and push their way onto only the best territories. And they'll specifically look for lakes where there are loon chicks. So chicks are a signal to males that this is a high quality territory. And these hostile takeovers can sometimes be pretty common. So one study found that territory holders will see off 2 to 5 of these prospecting males per day between April and August, and they'll interact with each male for up to 30 minutes each. So these attacks are almost military-like. The males in the prime of their life will scout out a really good place and then go in and viciously take it over. Now what's interesting is that if males get evicted from their territory, they'll typically go to a lake that's unoccupied, so they'll avoid a hostile takeover. And why this is still remains a mystery, but it's thought that evicted males might avoid fighting because males that hold a territory will lose weight every year. So apparently raising chicks and seeing off all of these unattached males really drains them. So after holding a territory throughout most of the prime of their lives, they may end up too light to successfully win these battles anymore. So apparently heavyweights rule in the loon world. Now females will actually follow a similar pattern. They'll get into these violent scraps with each other as well, but there is one major difference between males and females. and that's that females will never fight to the death. So why is there this difference between males and females? Why would males go to such great lengths to get and to hold territories, but females not so much? Well, it appears that for reasons that are unknown, males dictate where the nests are placed, not females. So males apparently have to learn by trial and error where a safe nest site is. And so their nest success increases the more years that they possess a territory. But if you think about it, the system is kind of wacky because the female who's already been on the lake should know where a good nest site is, but there's no transfer of knowledge from the female to the incoming male. And why this is also remains a complete mystery. And there are other mysteries in the loon world too. So after all this breeding season violence dies down, loons sometimes gather in these peaceful groups where they appear to socialize. So they'll swim around together in these weird formations. They'll form straight lines and swim in big circles. There's no aggression and there's no cooperative feeding. So what could they possibly be up to? Well, the answer is that we don't really know why loons form these social gatherings. The only hint is that gatherings tend to take place on lakes where there is a recent divorce. So it's possible that the gatherings could have something to do with shopping for new mates. And again, more data will tell. Now, something that I find really interesting about loon life history is that even though loons have this kind of violent side, they're also very nurturing and caring parents. So a lot of you might have seen this story last year out of Wisconsin, where a pair of loons raised a mallard duckling. So normally when loons interact with ducklings, it's aggressive. They'll attack ducklings and they tend to view ducks as their enemies. But during the breeding season, loons seem to be kind of hormonally primed to care for something. And it's thought that this duckling must have been separated from its mother and its siblings at just the right time to find a pair of loons that was really desperate to take care of something. So loons cared for this duckling just like they would a loon chick. They brought it food, they let it ride on their backs, and this duckling actually took on some loon behaviors. So it dove down to the bottom of the lake to pick up snails, which is really unusual for a duck or for a mallard. And this was actually a happy ending. So the duck ended up surviving all the way to the fall when it eventually left for migration. And this year, the similar thing happened when a pair of loons raised a gosling. And they did this in addition to raising 2 loon chicks. So loons can also be very nurturing. So loon natural history is certainly more mysterious than we ever thought, which makes loons a really powerful and intriguing symbol of the state of the environment, because it shows how we humans often think we know how the world works, when in fact we usually have only the most basic understanding. So now I'd like to shift gears and look at what this symbol of the wilderness is telling us about the state of the environment. So we've always known that common loons face a number of challenges when they're raising their young. For years, we've known that there are predators, there's human disturbance, and fluctuating water levels and disease. But in recent years, it's become very clear that airborne pollutants like mercury, and especially mercury interacting with acid rain, are some of the most important factors influencing the number of loons or chicks that loons produce. So in fact, the loon is now considered an iconic indicator of air pollutants in aquatic ecosystems. So in particular, loons are sensitive to acid rain and mercury pollution. So you can think of loons as being these little automated long-term water quality testing units. They float around every year and they don't need batteries or maintenance. And even better, with everything else being equal, they produce a really good readout of how bad the pollution is in a lake in terms of how many chicks they produce. So the biggest source of acid rain and mercury in the environment is the burning of fossil fuels. This comes from coal burning power plants, vehicle exhaust, and manufacturing and other industries. Now, a lot of you might be familiar with the acid rain story. How acid rain is produced is that when sulfur dioxide and nitric oxides are released into the atmosphere, they can interact with water to form sulfuric and nitric acid. And this acid will eventually fall to the earth as acid rain and then get into lakes and cause them to become acidic. Lake acidification is really bad for fish because it releases aluminum, which interferes with fish gill function. So this causes lower fish growth, reproduction, and survival in acidic lakes, which eventually causes there to be fewer fish in lakes that are more acidic. This is a problem for loon chicks because chicks rely on the lake or in the food in the lake where they hatch as pretty much their only source of food. So a lower abundance of fish on a lake means that there can be a shortage of food for loon chicks. They don't have enough of the food that they need to grow and survive. And this can lead to chick mortalities and lower reproductive success for loons. So the number of loon chicks gives a really good indicator of how toxic a lake is in terms of acidity. So mercury is also a problem for loons because they're at the top of the food chain. So when mercury from the atmosphere gets into water, it's taken up by organisms at the bottom of the food chain. And when a predator eats a prey, any of the mercury that's in that prey gets taken up by the predator. And so in this way, mercury reaches higher and higher concentrations as it moves up the food chain in a process called biomagnification. So eventually, when mercury gets into loons at the top of the food chain, it's at its highest concentrations, where it can be toxic. Adult loons with high mercury concentrations become lethargic and they spend less time incubating their eggs and feeding their chicks. And then chicks with higher mercury take fewer energy-saving rides on the backs of adults. They also have weaker immune systems and they're worse at avoiding predators. So the number of loon chicks is also a good indication of how contaminated a lake is with mercury. Now it's really important to note that mercury and acid rain interact in lakes. So lakes that are warmer and more acidic tend to have higher mercury concentrations. So how does this happen? Well, the mercury that's released into the atmosphere and enters into lakes actually isn't the type of mercury that's taken up into the food chain. Mercury first has to be converted into methyl mercury in order to get into organisms. There are a lot of different ways that this can happen, but the main mechanism is thought to involve bacteria. So when a lake becomes more acidic or warmer, these bacteria get really happy. They like these conditions and it causes them to produce more methyl mercury. This means that in more acidic and warmer waters, there's more mercury entering and going up the food chain. And so there's more mercury in loons. And this causes them to produce fewer chicks. So the number of loon chicks is a really good indicator of lake health. By measuring the number of chicks every year, we get a really good readout of how bad the pollution is in lakes. So remember how loons typically only fight over territories where there are loon chicks? It seems like loons are right in knowing that lakes with chicks are really high quality lakes. So this brings me back to the Canadian Lakes Loon Survey and why it's such a great program. So the Canadian Lakes Loon Survey monitors the number of loon chicks, which is kind of unusual in bird monitoring programs because most bird monitoring programs will look at the number of adults. But instead we're looking at chicks as an indirect measure of lake health. And also the Canadian Lakes Loon Survey has been running for nearly 40 years. So it's one of the most powerful data sets at Birds Canada. How the Loon Survey works is that participants select their choice of lakes to survey and they'll visit the lake a minimum of 3 times each year. So they'll go once in June to look for loon pairs, once in July to count the number of hatchlings per pair, and then once again in August to count the number of 6-week-old young per pair. And 6 weeks old is a really important stage when we're thinking about loon chicks. And this is because at 6 weeks, loon chicks are about 2/3 the size of an adult loon, which makes them less vulnerable to being eaten by predators. So chicks that are 6 weeks old have a much higher chance of survival and of becoming adult loons. So this figure is showing every location of a CLS lake that's been surveyed across Canada. So since 1981, over 4,500 lakes have been surveyed by over 4,000 people. Up to 735 lakes and 1,125 loon pairs have been surveyed per year. And this amounts to over 24,000 breeding attempts. So this is truly a remarkable data set. So what are all of these loon survey data telling us? Well, unfortunately, they're showing that reproductive success is declining across Canada. It's declining at a rate of about -0.1 chicks per pair per year. So this might not sound like a huge decrease, but if you look at this dashed horizontal line, this is at 0.48 young per pair per year. And previous studies have found that this is the number of chicks that are needed to replace any adults that have died. So it's the number of chick production that needs to occur in order for loons to have a stable population. So overall, reproductive success in Canada has stayed above this threshold, but if this trend continues, then loon populations could be in trouble. So these results are pretty concerning, and they beg the question, why are loons producing fewer chicks? Well, this is a really complicated question to answer because loons face many different threats. So as we saw before, lake acidity is a big problem for loons because it decreases the number of fish in a lake and it causes shortages of food for loon chicks. Mercury is also a big problem because it impacts adult and chick behavior and chick development. Human disturbance is also a problem for loons. So watercraft use can disrupt loon incubation and foraging and cause mortality when boats collide with loons. Shoreline development is a problem for loons because it can decrease the availability of good nesting sites and increase density of predators. And black flies are also an important problem for loons. So for anyone who's spent time up north, they know how annoying black flies can be. And if you can imagine, sitting on a nest trying to incubate an egg when you're being swarmed by black flies is also really annoying to loons. So it can actually be so annoying that the loons abandon their eggs. And eggs that don't get enough incubation time usually don't survive. So black fly harassment can actually impact loon chick production. The temperature and precipitation have an important effect on how bad black flies are that year. So in years with cool temperatures and heavy precipitation, black flies are more abundant and they live longer. And so in years with cool temperatures and heavy precipitation, nest abandonment is higher for loons because of black flies, which causes them to have lower reproductive success. Ice-off timing, which is also affected by temperature and precipitation, can impact loons as well. So ice-off is when the ice is all cleared off from a lake. And so in years with cool temperatures and heavy precipitation, you get later ice-off days. So in waterfowl, later ice-off dates are associated with delayed breeding and lower reproductive success. And a similar effect has been hypothesized for loons. There are also concerns that avian predators and competitors could affect loon chicks. So bald eagles are known to depredate loon eggs, chicks, and adults. And there are also concerns that cormorants can harm local fish populations and damage shoreline habitats. But results for both species are pretty contentious. And it's not clear whether bald eagles and cormorants actually affect loon reproductive success across Canada. Lake location is also important when we're thinking about loon chick production. So due to prevailing wind directions, more acid rain and mercury are deposited in eastern North America relative to western North America. This means that lakes that are further east tend to be more acidic and to have higher mercury. And for this reason, the risks of impaired reproduction are higher in eastern Canada. So this figure is showing the results of a study that looked in mercury concentrations in fish that loons commonly eat. And they used this information to estimate the risks to loons in terms of failed reproduction. So darker blue colors indicate a higher risk, and the more yellow colors indicate a lower risk. And you can see that there's a really strong west-east pattern here, where the risks of lower reproductive success are lower in eastern Canada, or higher, sorry, in eastern Canada. Lake size can also influence loon chick production, and this is because larger lakes offer several advantages to loons. So larger lakes tend to have more fish just because they're a bigger volume. They tend to be less acidic because they hold more acid buffering compounds. They also tend to have lower mercury, and this is because they can be deeper and cooler lakes, and also because they're less acidic. Larger lakes offer more potential nesting sites for loons, and it's easier for loons to avoid human disturbance on larger lakes. So larger lakes tend to have higher reproductive success. There are also threats that may not directly impact reproductive success, but they could affect there are other threats that may not directly impact reproductive success, but could indirectly impact how many chicks loons produce by affecting the health of adult loons. So in recent years, there have been these reoccurring annual die-offs of sometimes tens of thousands of common loons due to type E botulism, and this is in the lower Great Lakes. We don't really understand how these botulism-induced die-offs impact common loon populations, but it may be having a serious effect. During the winter, because loons spend their time on the ocean, marine oil spills can also be a big threat to loons. Oil is toxic to loons when it gets on their feathers or when they ingest it, and it can be immediately toxic to loons, causing death, or it can have long-term impacts like reproductive impairment, lower immune function, and impaired migration. So here I'm showing the Deepwater Horizon oil spill in 2010, and common loons were actually some of the most impacted species. Lead poisoning is also important for loons. When loons ingest fishing tackle, they can also ingest toxic lead. And in some US states, mortality due to lead accounts for 40 to 71% of annual adult mortality for loons. And the last factor that I'll talk about here is habitat loss due to climate change. So this figure is showing the predicted changes where you would expect to find loon habitat in now versus in 2080. And you can see that there's predicted to be a northward shift in loon habitat due to climate change. And it's unclear whether loons will actually be able to keep up with this shift in where their habitat is found. It's also predicted that loons will lose 56% of their current summer habitat and 75% of their current winter habitat due to climate change. So clearly, there are a lot of different factors that threaten loons and could affect their ability to produce chicks. And so the goal of my postdoctoral research was to identify which factors are contributing to loons producing fewer chicks across Canada. But I focused on Canadian Lakes Loon Survey data from Ontario, and I did this for several reasons. So the first reason was that the Canadian Lakes Loon Survey started in Ontario in 1981. So Ontario had 38 years of data to analyze, and this is almost a decade more than other provinces. Ontario was also the province with the most lakes that were surveyed, so it had data for 1,700 lakes. Ontario is also home to over a third of the entire global population of loons, so data from Ontario represent a large proportion of the total common loon breeding population. And also, many lakes in Ontario were heavily impacted by acid rain and mercury. So looking at data in Ontario allows me to compare lakes that were highly polluted to lakes that are relatively pristine. And the thought here is that results from Ontario would be applicable to the rest of Canada. So for my study, I ended up exploring support for 17 factors that were known or hypothesized to affect loon reproductive success. So I looked at lake area, longitude, pH, fish abundance, shoreline development and boating activity, bald eagle and double-crested cormorant occurrence, yellow perch mercury concentrations, spring temperatures and spring precipitation, and winter precipitation. And I obtained all of these data from various different sources. So the first result was that in Ontario, reproductive success declined between 1981 and 2018. And actually declined at the same rate that we were seeing across Canada. And just like across Canada, reproductive success is still above that reproductive rate threshold that's required to maintain a stable loon population. Now I found that 5 different factors were contributing to these declines over time. These were lake area, longitude, pH, yellow perch mercury concentrations, and April temperatures. So first I'll walk through the results that I was expecting to see. So as we would expect, smaller lakes had fewer loon chicks. This is what was expected because if you remember, larger lakes offer several advantages to loons in terms of food, acidity, mercury, nest sites, and human avoidance. Also as expected, more acidic lakes had fewer loon chicks, and there were steeper declines in chick production over time on lakes that were more acidic. We actually found that in lakes that were pH 4.5, reproductive success fell below that reproductive rate threshold. And on lakes that were less than pH 6, reproductive success fell below the threshold in the mid-2000s. So these data are suggesting that loon populations could be more vulnerable to declines in lakes with that are more acidic. Now, also as expected, lakes with higher mercury also had fewer loon chicks. Now as well, I found that years with cooler spring temperatures, so cooler April temperatures, had fewer loon chicks. This is also what we would expect because cooler springs would have more black flies and later ice-off dates. So the results are supporting both of these predictions. And now for some unexpected results. So I found that loon reproductive success actually increased with longitude, so it was higher in Eastern Ontario. And the decline in reproductive success over time was also shallower in Eastern Ontario. And it actually, in Western Ontario, it was reaching that reproductive rate threshold. So what was going on here? Well, if you remember, this was unexpected because in Eastern Canada, the risks should be higher to loons because this area received higher mercury and acid precipitation. But we think that Ontario might be an exception to this trend because the area in Eastern Ontario that we're looking at actually has soils with high buffering capacity. So even though this area received high acid and mercury pollution, the risks of reduced productivity are actually lower in this area. So what about the results where we didn't see any effect? So specifically, I want to talk about human disturbance and bald eagles and double-crested cormorants. So I actually found that reproductive success for loons was higher on lakes where there were bald eagles and double-crested cormorants. So there was a slightly higher reproductive success on lakes where bald eagles were present, and the declines in reproductive success over time were not as steep on lakes where cormorants were present. So I think that this has to do with all three species having similar habitat preferences. So bald eagles, cormorants, and loons are all fish-eating birds, and they like lakes that are bigger and have higher numbers of fish. So our results suggest that lakes with bald eagles and double-crested cormorants also provide good breeding habitat for loons. And what was interesting is that we found that human disturbance had no effect on reproductive success. But we actually think that human disturbance is probably really important. It's probably so important that loons avoid breeding on lakes where there's high human disturbance. So because reproductive success is measured as the number of young per pair, we can only measure reproductive success on lakes where pairs are present. So we're thinking it's probably possible that the reproductive data don't reflect human disturbance because you can't measure reproductive success if there are no loon pairs. So in summary, across Canada, common loons produced fewer chicks between 1992 and 2018. And data from Ontario showed that acid rain and mercury are likely driving the declines in common loon chick numbers. Loon productivity was lower on smaller lakes and in years with cool spring temperatures. And lakes with bald eagles and cormorants did not have fewer loon chicks. And finally, the number of young per pair is probably not a good indicator of human disturbance. So for the last part of my talk, I want to focus in on these acid rain and mercury results, because in some ways, these results are unexpected. So these graphs are showing sulfur dioxide, which is the compound that produces acid rain, and mercury emissions in Canada between 1990 and 2018. And they're showing that emissions of sulfur dioxide have dropped by 73%, and emissions of mercury have dropped by 91%. So if acid rain and mercury are decreasing, then why are we still seeing that acid rain and mercury are problems for loons? Well, for acid rain, essentially it's taking lakes a really long time to recover. So acidification is usually associated with other chemical changes, like decreasing calcium concentrations, which can harm animals in lakes and upset lake food chains. And in some cases, even though acidity has decreased, it's not always possible for fish to reestablish themselves on lakes where they've been eliminated because of acidity. So decades later, we're seeing that these lakes still haven't recovered. Now, the problem with mercury is that it's very persistent. So once mercury enters into the environment, it's there to stay. So mercury will cycle between the air, the sediment, and water, but it's never completely removed from the environment. It's just moved to other locations and eventually buried in soils and sediments. So mercury and acid rain are still big problems. And it's possible that climate change could be intensifying the effects of acid rain and mercury. So climate change models are predicting an increase in the frequency and severity of hot summers and droughts. So this figure is showing how droughts could affect lake acidification. So it's showing an S in the soil for sulfur and sediments, and an O2 here for oxygen and air. So when water levels draw down during a drought, this sulfur is exposed to oxygen, and then it becomes sulfate, which is the chemical that's responsible for lake acidification. When water levels rise again, this sulfate is washed into water, which can cause lakes to reacidify. And these changing water levels are also affecting mercury concentrations. So this study by Watrous and colleagues found that the mercury in fish and in loons actually tracks regional water level oscillations. And so climate change models are also predicting that water level fluctuations are going to be intensifying with climate change. So we would expect that loons would experience higher and more frequent mercury exposures over time. Climate change is also predicted to increase the frequency and severity of forest fires, which are also known to increase mercury emissions into the air, into soil, and into water. And in fact, a recent study actually found that fish mercury concentrations are increasing in Ontario. So you can see that by these darker red colors, which are showing higher rates of mercury increases in fish. And the study by Chen and colleagues actually linked these mercury increases in fish to global climate change indicators. So it's possible that the negative effects of climate change and of mercury could already be affecting loons. So based on all of these data and what we found for loons, we hypothesized that through climate change, acid rain and mercury could be contributing to lower loon reproductive success over time. So all of these data are pretty depressing, and you're probably thinking, are loons in trouble? Well, the short answer is yes. Common loons are in trouble in Canada, but luckily there's still a large population of breeding common loons. There's an estimated total number of 264,000 breeding pairs in Canada. And also, the Canadian Lakes Loon Survey data are still showing that loons are above that 0.48 threshold. So there's still time to help loons, but hopefully if these trends continue, then the populations will start to fall apart. But hopefully we can mitigate these effects. And the good news is that there's still time to prevent loon population declines. And there are a lot of meaningful ways that people can help to support loon research. A really great way of helping to support loons is by taking part in the Canadian Lakes Loon Survey. So none of this research would have been possible without all of the citizen scientists who took part in the Canadian Lakes Loon Survey. So by monitoring loons, you can collect critical information to help loon conservation. You can also support avian research and conservation by supporting Birds Canada. You can lobby for loon and lake conservation in your area. And also, if you visit a lake every year, you can help by keeping lakes clean and by letting native plants grow along shorelines. These native plants provide food and shelter for chicks. And also,
Oh, folks, look like we've lost Kristin. We're just gonna try and see if we can get her back here. Just
the CLLS.
Hey,
Tracy
Kristin.
Parker. Oh, hi.
Sorry to interrupt you. We lost you there for a little bit there. So if you could just go back and redo that slide.
Okay. Sorry, this one here?
Yes.
Oh, okay. I can just start from the beginning? Or...
That would be great. Yeah, we lost you pretty early.
Sorry. Yeah, so really great ways to help loons are to take part in the Canadian Lakes Loon Survey. So by helping to gather research about loons, you can help us to understand what's going on with them. You can support avian research and citizen science programs by supporting Birds Canada. You can also lobby for loon and lake conservation in your area. And if you normally visit lakes during the summer, a really great way to help loons is by keeping lakes clean and letting native plants grow along shorelines. So these native plants provide food and shelter for loon chicks. And a really easy way to help loons is by slowing down and by minimizing wakes when you're boating to avoid disturbing loons. So by minimizing wakes, you prevent washing out loon nests, and you prevent little chicks from being separated from their parents. All right, so there are a lot of people to acknowledge for helping with this work. So none of this work would have been possible without the Canadian Lakes Loon Survey citizen scientists. Thanks to Kathy Jones for coordinating and promoting the CLLS, and Tracy Barber for data processing. Thanks to my supervisors and co-authors, Doug Tozer, Mark Mallory, Rob Alvo, and Satyendra Bapsvar. And also thanks to the researchers who shared the additional data that I used for these analyses. I'd also like to thank all of the organizations that supported the CLLS. And I'd like to thank MyTax, the Bluffs Hunting Club, SC Johnson, Akita University, and Birds Canada for funding. Yeah, so I would be happy to take any questions.
Okay, thanks so much for the presentation. I thought it was a wild ride with murder mystery and divorce and bacteria with angry eyebrows. That was great. I think we have one question in the chat.
Sure do. Yeah, I have to say, I didn't know that they were premeditated murderers, so that was all new to me. So we do have one question here. I think you've answered it a little bit, but maybe you could expand on it. So the question is, are there differences between provinces or ecoregions in the degree to which loon chick numbers have decreased? And specifically, how is Alberta doing?
Oh, that's a good question. So I've been putting together a report for Birds Canada that was looking at each province separately. So this information is really fresh. So it seems like certain provinces aren't doing very well and other provinces are doing okay. So Alberta looks like it's one of the provinces where there are variations from year to year, but overall it seems like there's kind of a stable trend. So there's no significant decrease in chick production in Alberta over time. But yeah, it just depends on which province you're looking at. So most other provinces are showing decreases, but I think it's Alberta, and if I'm right, I think Manitoba is also doing okay. But every other province we're seeing decreases.
Can you, for the folks who are on the webinar from Alberta, can you maybe mention what sort of training is involved in participating in the survey?
Oh yeah, there's really no training required and not very much equipment either. So you just have to visit a lake at least 3 times a year. And Kathy Jones, the volunteer coordinator, will send this little packet and it shows kind of what to look for. So you have to look for loon pairs, which are pretty easy to spot. And then you have to look for small chicks, so the little downy guys. And then it'll show, like in August, the loon chicks should be about 2/3 the size of an adult loon. And so you're just counting to see how many chicks have reached that stage, because that's really the critical stage that we're looking for when we're measuring reproductive success. So yeah, there's no real training that's required. You just have to kind of know how to look for loons, and that's it.
And also, I think, is it just one species of loon in Canada, or do we have the Pacific loon as well?
Yeah, there is a Pacific loon as well. I'm kind of new to the loon world, so that's a tough question for me. I should be able to answer that. Yeah, there's the Pacific, and I think, but that wouldn't be found kind of throughout Canada the way the common loon is. Yeah.
Excellent. We've got a couple more questions here coming in through our Q&A function. So I'm just going to remind people that along the bottom of your screen, you should see the Q&A. So if you have any questions, type them in there and we'll get to them. The first one here is, do you think that climate change and mercury will still impact loons in the absence of acidification effects, as Alberta lakes are generally well buffered?
Yeah, well, mercury is still a problem even if there isn't lake acidity. So I was kind of looking at the acid rain story because it was a really big problem for loons, especially in the past and especially in Ontario. But it seems like mercury mercury is kind of increasing, especially if you look at global emissions, not just emissions from North America, which have kind of been brought under control. But if, like mercury on its own is a problem for loons. So even if a lake isn't acidic, if there is high mercury, it's still going to be a problem.
Thanks for that. And then the last one here is a little bit more of a comment, but it's just asking about if there's a familiarity with kind of northern Alberta Grist Lake, how there's large flocks of approximately 85 loons. No evidence of babies, but it definitely has lots of fish.
Oh, sorry, I missed the first part of that.
Oh, it was just it was more of a comment on familiarity. As in northern Alberta, there's a lake where there are apparently 85 loons, but there's no evidence of babies. So I think it was framed as what could be a reason for that.
Oh, well, there are some lakes. It just depends on kind of the time of year that you're thinking about as well. So if it's during the breeding season and there are tons of loons there and no chicks, then that's pretty depressing. Then there could be something going on in those lakes that loons aren't producing chicks. But if it's in the fall, it could be one of those social gatherings where a whole bunch of loons are kind of gathering and doing whatever it is they're doing in the fall for those kind of social type formations that they do. So it kind of depends. I know there are some lakes, there's one in Saskatchewan called Anglin Lake where there are tons and tons of loon pairs, and there's actually really high chick production because they have a lot of fish there. But yeah, I'm not familiar with that particular lake, so you just have to kind of know like what's going on with the lake chemistry and the time of year and everything. So a lot of different factors can come into play there.
Thanks for that. This one's kind of related. So a different lake, on a lake in BC, where the question asker says, I see adult loons but no chicks. The lake level changes drastically. Would it help to build a floating loon nest for them?
Oh, sometimes. I know it depends on the lake and the conditions for those floating rafts. In some cases, it can be really good for loons because it provides a really good breeding habitat, especially if the lake water levels are changing, then the nests aren't going to get washed out. But I know you have to be careful on where you put them because sometimes it can be a really good attractant to predators. And so it actually creates kind of a trap where loons think it's good habitat, but then these predators can get to it really easily. So it'd be something that you'd have to look into on that particular lake to find out whether it would be a benefit or not.
I wonder if most of the lakes that you looked at for your research in Ontario were kind of low productivity lakes, and if there's any correlation between the trophic status of a lake and how well loons do there.
Yeah, that's a good question. Yeah, we haven't looked at like the food webs on these different lakes, but that would be something that would be really interesting because yeah, if the lake if they have a higher trophic level, presumably there would be more mercury. But yeah, it's I'm not sure in terms of, so yeah, the production level, like it depends on where you're looking at. Like I did a separate study kind of around Sudbury, and which was really highly impacted by acid rain. And so in that area, productivity is very low. So so we're seeing really steep declines over time and really terrible productivity. Like I was there last year and there were 2 chicks total on 94 lakes that we visited. So it's doing really poorly. But in terms of other areas, like you'd have to look at each lake individually. And unfortunately, my study was just looking at so many lakes that we couldn't really zoom in to see like regional productivity. So I know Sudbury is doing bad, but in terms of like all these different areas, I'd have to look at the data in more detail.
Are there any other questions from anyone on the panel?
Yeah, I've got a question. Have there been similar studies with other diving birds, such as like the various grebe species, and are we seeing similar trends with mercury and acidification?
Yeah, that's a good question. I'm not sure. I don't know offhand whether those studies have been done, but that would be something that would be really interesting to look into because presumably they would be affected as well. I think everyone just really loves loons, so it's a popular bird to look at.
Okay, I don't see any other questions in the chat. Anything from anyone on the panel, Jenna, Caleb? No?
Nope. It was a
Okay.
very good presentation.
Yeah, thank you so much for the presentation. I'm
Yeah,
hoping through this webinar that we can get a little bit more data on loons from Alberta, and that folks will start collecting that information as they're out collecting water quality data through some of our programs. So I'm hoping we can help beef up your data set from Alberta a little bit.
Yeah, that would be great.
Okay, thank you so much for the presentation.
Yeah, thank you.
Okay, so we have our next speaker ready to go here. So I think we'll just hop right into our next presentation. Our next speaker is James Littley. He's from the Okanagan Basin Water Board. And we invited him to speak with us about milfoil today. As a background, through some of the Alberta Lake Management Society work, we've been collecting milfoil specimens and sending them off to a genetics lab to make sure that they're a native variety and not the invasive eurasian milfoil. This year, I think we sampled 24 lakes, primarily through our friends at the North Saskatchewan Watershed Alliance. And we didn't find any eurasian milfoil. We did find, or our friend Michelle did find one species of world milfoil, which was very exciting for us to find something different. But I think it's important to hear from a jurisdiction that is dealing with this invasive plant. So I want to thank James for joining us today, and I think we'll just pass it over to you.
Great, thanks Bradley, and good morning everyone. Today, as Bradley said, I'm going to be talking about this attractive looking plant, although it's not nearly as beautiful as loons I learned this morning, which also happens to be invasive and harmful. So it's Eurasian water milfoil. I'll be talking this morning about why the plant is harmful, what's been tried over the past 50 years to control it, and how it's controlled now in different places. I'll also talk about the costs associated with our control program and the economic impact it could have if we didn't control it. And then of course, I'll be happy to take some questions. So what is the Okanagan Basin Water Board? We are a unique local government agency, which is a partnership between 3 regional districts in BC. Those are governments akin to your counties, I believe, in Alberta. We were established in 1970, which was actually as a response to the new infestation of milfoil and other water quality issues linked to raw sewage being dumped into our lakes. So our mission is to provide leadership to protect and enhance the quality of life in the Okanagan through sustainable water management. And we do this by defining water problems and priorities, the economic feasibility of solutions, responsibilities, necessary legislation, and required action. Invasive milfoil was first introduced into the Okanagan in the late 1960s, likely as an aquarium plant or from a watercraft coming from another infested North American lake. In the early 1970s, there was a major public effort to stop the spread of this weed. And you can see here a bumper sticker that I actually found in our storage room from the 1970s in the bottom of a box recently. The province of BC conducted experiments to eradicate milfoil for almost 10 years and spent even longer on finding a good method for controlling the weeds. By 1994, the province fully downloaded the control of invasive milfoil to local governments, and that's when the Okanagan Basin Water Board formally took over all of the program and all of the costs. This is a picture of the north end of Osoyoos Lake, which has ideal conditions for Eurasian milfoil. It's sunny and hot. There's a lot of light penetration. It's relatively shallow water, and it's surrounded by orchards and other agricultural activities, so there's a lot of runoff from fertilizer. What does the milfoil do? Well, it outcompetes native plants. It grows up to 5 centimeters a day in good conditions, and it forms these thick mats on the top of the water. So it's an emergent aquatic macrophyte, grows out of the top of the water, flowers, and then keeps growing and flops over on itself. This causes temperature changes in the water, so the surface of the lake gets very hot and the bottom of the lake gets very cold, prevents oxygen mixing, and also once the plant starts to die off and deteriorate, that decomposition process takes a lot of oxygen and it creates anoxic conditions and it can actually lead to fish kills. So it's a plant that can grow so thick it literally suffocates fish. It stops light penetration by forming these dense canopies on the surface of the water, and so that outcompetes native plants. And I will say when we are able to control this, or where we control it, we do often see the resurgence of native plants. From a recreational standpoint, anyone who's gone through a thick bed like this with their boat knows that it can seize a power boat prop. It also creates a nuisance and a hazard to swimmers, and it has been attributed to drownings in the States. So on the left here, you can see a shallow, uncontrolled area at the Kelowna Yacht Club, and this is simply an area that our machinery can't get to. On the right is a pile of milfoil weeds that have been collected from the lake and transported to shore for removal. So this gives you an idea of the volume of plant material that we're removing. This is a shot from Vassaw Lake in 2016. Vassaw is a small lake in the South Okanagan. This is an uncontrolled lake for milfoil because it's a bird sanctuary and there's a no motor vessel restriction. Now the lake isn't always this bad, but this was a severe outbreak, and milfoil does tend to be cyclical. In some years it's really bad like this, and in other years it's barely noticeable in some areas. This also increased algae blooms. So I mentioned those anoxic conditions that it creates, changes in light and temperature, creation of standing water. This grows so thick that it prevents the flow of water or even wind-driven waves, and therefore changes the water chemistry. So from the same guy who took the picture of Vassaw in 2016, he went out on his beach and collected all these fish within about a half an hour in 2016, and then he took them to a biologist and they determined that they had suffocated essentially. So milfoil actually spreads by fragmentation. Like I said, it grows to the surface, it emerges, and then any part of the plant that breaks off through winds or waves or boats going through it become viable new plants. So you don't need the flower or the root or a seed or anything. Any section of the milfoil can float around and reestablish itself. What does this mean for property values? Well, one study out of Washington State said that thick and dense milfoil infestation on a waterfront property can reduce the property value by up to 19%. Now, the average lakefront home in Kelowna in 2015 was $2.3 million. It's closer to about 4.5 now. So that means in 2015, it could reduce that home value by $437,000. Just for additional context, and I'm going to get back to this later, but the assessed land value for our region this year is almost $92 billion. So here on the top, I've captured a screenshot of the Kelowna foreshore on Google Earth, and the blue shaded parts are actually our permitted milfoil areas. These shaded areas just on the Kelowna foreshore cover about 5 kilometers of the most high value public and private shorelines in the Okanagan. This includes the Kelowna Yacht Club Marina, which is one of the largest freshwater marinas in Canada with over 1,000 boat slips. It also includes City Park and several of the busiest beaches in the region. And I'm sure folks from Alberta, about 95% of you have spent a summer or at least gone to a beach trip in the Okanagan, so you'll know a lot of these areas. At the bottom, you can see the type of shoreline that we're talking about, and you can imagine how this would not have been possible if the lake was covered in thick mats of milfoil. Altogether in the Okanagan, we have permits for over 50 linear kilometers of shoreline. They don't all get treated every year, but they're the areas that we've identified as high public value that need to have the milfoil controlled. So now I'm going to get into what options have been tried, and then I'll talk about which options we still use today. You can see that people have been trying to come up with machines for controlling milfoil ever since the 1890s. And everything from a simple pitchfork to a steam-powered barge. And I just want to point out, I assume you can see my cursor, but on the bottom right of the machine, you can see these teeth that look like a hedge trimmer. And this is what we use today in the summertime. It's an aquatic harvester. It's no longer steam-powered, but it's a paddle wheel-driven barge. The front end here has those same kind of hedge trimmer teeth on the side edges and along the front, if you could see it. So that front conveyor belt actually goes down about 5 or 6 feet into the water, cuts the milfoil off, conveys it into the belly of the machine under the operator, and then they will back the machine up to shore once it's full, and this is a secondary conveyor that offloads it into those big piles that you saw on the beach. This is what happens once it's on the beach. We have to have a milfoil transfer site which is stable enough on the shore side to hold a 10-ton truck and within the reach of the grapple on a crane in order to pick it up. But on the water side, it has to have deep enough water for the machine to get into that area. And as we all know, there's increasing shoreline development, and so we've been continually losing these transfer sites, especially in the last 5 or 6 years. Even areas that are owned by municipalities, we will have been using them for 30 years, will show up one year and they will have been landscaped and irrigated and blocked off, turn into beautiful parks. But of course, there's not much we can do about the milfoil management in the summertime if we don't have these transfer sites. So the good thing about harvesting is that it's cost effective. You get an immediate aesthetic improvement to your beaches, and it also removes sequestered nutrients, particularly phosphorus and nitrogen from the water by removing all that biomass. The cons are that it has no long-term effect, and I've put the friendly lawnmower with the bag on there because it's just like cutting your lawn with the bag on. A couple of weeks later, you got to do it again. It requires that onshore infrastructure. And of course, it can create conflicts with beach and lake users and recreation because it's a summertime activity. So we do have to go into the swimming areas and put signs out on beaches that say we're operating there. And our operators have to be very careful. And also because we are operating flat bottomed barges, we get speedboats running around us and wake boats, and they can make the machine pretty unstable. Another thing that has been tried is suction dredging. Now this photo isn't actually of suction dredging per se. The real suction dredge would go down into the bottom of the lake and take the substrate off with the milfoil and roots. This is what they're calling diver assisted suction harvesting. So the diver is actually hand pulling the weeds and then feeding them into the dredge so that they can be pulled up more easily. Now, this was tried for a while and it sounded cool because they would say, well, one of the benefits is that the lake bottom is reclaimed. You end up with a nice sandy hard packed bottom. And they said, well, it'll also increase land value, which anything that controls milfoil can. And the idea was that they would take all the substrate material and put it near a park and actually create more park area. So they said it could create new parkland by removing the bottom of the lake and turning it into land. The cons are that, of course, it dramatically disturbs the ecosystem. It required large holding areas on land. The retaining areas often were stinky and wouldn't be very nice. I don't know who would want to recreate on parkland that was like that. And of course, it's expensive and there are significant worker safety concerns. This is the next method. So this is aquatic rototilling, or it's called rotovating sometimes. And you can see on the front of the machine, the rototilling head is just a cylinder with blades on it. And it's attached to the machine, to the barge on either side with these long arms. And those long arms can move this way down into the water. On this particular machine, it goes down about 20 or 25 feet. This is the largest machine we have. And it simply churns up the substrate about 6 or 7 inches, and depending on how hard packed the bottom is. And that creates, that causes the roots of the milfoil to float to the surface. And because we only do this during the winter when the water temperature is below 10 degrees Celsius, the plant is dormant and those root fragments can't reestablish anywhere. So the pros of rototilling are that it actually reduces 80 to 90% of the density of the stems in one treatment. And after multiple years, you can essentially like eradicate it for a few years in a specific area. If it's left for another couple of years without rototilling, then the milfoil will reestablish and grow back. It doesn't require the onshore infrastructure except for obviously some large boat launches. There's limited conflict with seasonal beach users because not many people are out on the lake in the winter, and it's also relatively inexpensive. Again, though, it dramatically disturbs the ecosystem because you are churning up the substrate. In new areas, there's the potential to release toxins that have been otherwise sequestered in the layers. There's worker safety concerns, which I'll come back to in a second. And you're also limited by the winter conditions. So talking about worker safety concerns, here was a little adventure for our operator. You can see the whole hull of the machine. The barge section is actually submerged already. He's turned off the close paddle wheel because it's no longer effective being halfway in the water. This was just caused by a hole in the barge. And he has his lifeboat unlocked, ready to go, his door open, ready to hop out, and he's just racing to make it back to shore before the machine sinks. Luckily, he made it with just sinking at the boat launch so the machine could be easily recovered. And I mentioned the winter conditions, so more so in earlier years, but we'd get frozen lakes, especially the small lakes, so that can affect our operations about which lakes, which areas we do, and we have to be pretty methodical about doing the smaller lakes early in the season and late in the season and avoiding that freeze up. But it's not as much of a problem now with climate change, and at least now the employees have heated cabs to work in. My last slide will show what it used to be like. And then another form of kind of rototilling, but it's not actually turning, is just a tractor-mounted agricultural harrow. And it just drags these teeth through the substrate. It has the same derooting effect roughly, but we use this only in very shallow water. The machine is just a tractor. It's limited to about 1 meter in water depth. So a lot of our public beaches are very shallow and go a long way out. We had one case where the machine went over a drop-off and had to be recovered. And we need to also avoid soft spots. And this is what I mean by soft spots. In 2016, I was actually on board when the operator and I decided to take a new path and ended up in a kind of a creek bed in the bottom of the lake and sunk the machine. This is a 40-ton crane in the background that came to rescue us, and they had a 10-ton winch on the front of it. And even with both of those, they couldn't pull us out. It was actually dragging the barge with those kind of pylons or whatever they're called down into the substrate. It was dragging the whole barge towards the machine. So the next day we had to hire divers to go down with compressed air hoses to get around the bottom of the machine to break the suction from the mud, and then the crane was able to extract it. So that was quite an adventure, and as you can imagine, the operators don't like to have me on board too often now. Another thing that was tried early on was chemical treatment, and it's still used fairly extensively in the States. So early on, we tried diquat and 2,4-Ds. But you can imagine if this is your beach or your drinking water and you see these people out in hazmat suits and gas masks, people got upset and they didn't like it. And so this is what it led to. This is from one of our file photos from here in the Okanagan, protesting the use of chemicals in our drinking water. So there's no social license then, and in every conversation I ever have about chemicals, there's no social license now to use them for the weeds. Now the pro of these early aquatic herbicides was it killed stuff, but there were a lot of cons. The herbicide was shown to drift up to 2 kilometers from the treatment site. It scared people, as I showed. There was also very mixed results. So it's not just about the chemical, but about the way it's delivered. So you can't just spray it over the top of the water. They had little pellets that were kind of coated in 2,4-D that were meant to sink down onto the plant. And those didn't really work. The chemical kind of came off and it killed the top of the plants, but didn't really get into the root system. So you'd need to treat them annually or at least every second season. And those early chemicals were really not selective. So you'd kill any sort of plants in the water. Another thing that was tried was water jet dredging. The province actually held a contest in the 1980s, I believe, for anyone in the public to come up with a concept to design a machine to control milfoil, and one was water jet dredging. And so this is a quote from our website. The intention was to dislodge water milfoil roots from the lake bottom, but every so often the device would become stuck and create a hole in the sediment several feet deep. This work was being done in January, and of course, to get out to the lake, to the machine, we used the latest high-tech transport, which was chest waders. The holes left by the water jet were easily located by the screams of the crew members. So the next thing that's been tried and is still marketed in some places today is weed barriers or bottom barriers. And this is basically akin to landscape fabric that gets anchored down with rocks on the lake bottom, covers the surface, prevents light penetration, prevents the plants from growing. It does reduce the weed growth and it can provide excellent results for about 1 to 3 years, but you're covering the entire substrate of the lake. And so obviously it dramatically disturbs the ecosystem. It would interfere with spawning, it would interfere with mussels, a lot of turtles, hibernating turtles, and of course native aquatic plants as well. It also requires regular cleaning and maintenance. And one of the issues is that if you put it on top of a milfoil bed, once the milfoil starts to decompose, it releases a lot of gases, and that creates bubbles which eventually tear the fabric and make it not useful. And then within a few years, the silt ends up covering the fabric anyway, and it leads to the regrowth of the milfoil, so it'll just grow right on top. And of course, it's very expensive to buy this in large quantities. So these are biocontrols that were considered but not tried. One was herbivorous fish like grass carp. Turns out they really don't prefer milfoil over other types of aquatic weeds. And we do, I believe, have grass carp in our lake now, and they're invasive, but they're not controlling the milfoil. Aquatic snails would have had a minimal effect on milfoil. Crayfish were considered, but they also predate native fish eggs and zooplankton. And I love this quote from the study I was reading: "The introduction of exotic species of crayfish into the Okanagan at this time does not seem advisable." They also considered competitive plants like water lilies and American lotus, which could outgrow the milfoil and reduce the light penetration. And then they would use chemicals to remove those plants. So that wasn't a good idea and wasn't tried. And then there are also phytoplankton and types of dyes that can be used on the surface of the water to reduce light penetration, but it's not feasible in the Okanagan. I mean, Okanagan Lake is about 120 kilometers long. As I said, we treat about 50 kilometers of shoreline and 5 major lakes, so you're not going to be able to dump that much dye or phytoplankton anywhere. And they also explored the use of pathogens, but they were found to not be, that they wouldn't be effective. So the winter today in the Okanagan is still the summer harvesting and the winter rototilling. And as well, we still use the small shallow water tractor on our beaches. So from 1994, when we took over the program, till 2013, it was really status quo. We would do the rototilling in the winter and the harvesting in the summer. And our operators actually didn't even have mapped out areas. There was flexibility for them to identify the milfoil and just go out and treat it. But in 2013, and really a little bit before that, there really started being some concerns about our treatment methods and a species concern, particularly about a new species, not a new species, a species of mussel which was newly thought to be at risk or endangered. And that is the Rocky Mountain ridged mussel. So in almost the first 100 years, from about, I think, 1903 to 2003, there had only ever been 100 recorded occurrences of this mussel. Now, the mussel does exist from Southern California all the way up to the north end of Okanagan Lake and across much of the northwest of, or the west of North America. But the Okanagan is the only area in Canada where this mussel has been found to exist. And so that's one of the federal criteria for listing a species as endangered, is having an extremely limited geographic region. What happened was the province had listed it as at risk or endangered, and the federal government was considering listing it as endangered. And so the province was doing more studies. They hired a Norwegian mussel expert to come over to Canada, and they did surveys of 9 sites in 2015 and found thousands of mussels that thousands of this species of mussels that no one had identified before, including recent healthy juvenile recruitment, or in other words, young mussels that had been recently born. I don't know if mussels are born. Anyway, new mussels. But at the same time, there were new regulations brought in that prohibited rototilling at several Rocky Mountain ridged mussel sites, even where we'd been doing it for 30 years and where they had shown that there were healthy populations and recent juvenile recruitment. One of the questions that we're looking at researching this year is whether Rocky Mountain ridge mussels can even live in thick milfoil beds, because there have been no studies about this yet, and because mussels can't live in anoxic conditions, and they also need a certain amount of water flow because they're filter feeders, which ultimately probably does not mean that it's conducive for them to live in milfoil beds. However, this new restriction also caused us to significantly modernize our operations. And so I showed you these polygons on the Kelowna foreshore. It was a different angle, but this all stemmed from these new habitat concerns. Actually, I'm just going to go back there. We created these new polygons. There's over 200 of them, and they're GPS tracked. And now all of our machines have iPads on board. We GPS track all of our work every year. We submit that to the province, and then it also shows if the milfoil is migrating anywhere, even within a couple meters of the site that we had initially drawn out. Then every year we can slightly amend our permit to include that area and make sure we're still being effective. But we can't any longer just go into a new area that hasn't already been permitted and studied without getting a permit from the province. And so each of those 200 polygons now comes with a table of information, and this is a Google Earth platform, which makes it really easy for me because folks will phone me and they'll say there's milfoil in front of my property. I can look up their address on Google Earth and find out whether we have permits or not, what it would take, whether there's mussels in the area or kokanee spawning area, all those sorts of things, and can give them an answer on whether we can do anything immediately or not, or whether we would need to get a permit to treat milfoil. And often what happens is homeowners aren't really sure if it's milfoil or not. They just know there's weeds in the lake and they really want them gone from their private beaches. And we'll end up going out, and a lot of times there's very little milfoil, or it's another type of weed that we can't treat. So each of these information tables tells us a polygon number, a name for that area, tells us what kind of cover type it is. So in this case, you see it's a uniform 100% milfoil. It's dense 71 to 100% cover. There's no other plant species number 2 or number 3 here. This has the foreshore inventory mapping segment. So that gives our environmental contractors an idea of what other kind of sensitive habitat might be there. Aquatic habitat index rating. So the foreshore is more on land for sensitive plants and things. Aquatic habitat is more in the water. It tells us a kokanee zone, which we have in the Okanagan kokanee salmon, and they can be black, yellow, or red zones, or no color zones, and that dictates the type of work window we have. So here you can see that it's we're allowed to treat this area from July 22nd to August 24th and October 15th to April 1st. There's no sensitive plants and no mussels in this zone. And then we don't harvest here, we only rototill here. So our operators have the iPad with all 200 of these on board on their maps, and they can do the same thing when they get into a new area, check all of this information, find out immediately about any habitat concerns, make sure they're in the right work window, and we can even put hazards. So there are, heat exchangers from our general hospital in the water, there are electrical lines, there are people's anchors, anything that is in the water we can potentially mark on the maps for our operators as well to avoid them. So what else could we try? Well, I like to watch Star Trek, and so I was thinking about the USS Enterprise firing phasers at the milfoil. And I wanted to put a picture of the Starship Enterprise firing phasers, but I didn't know about copyright infringement. So another thing that's been tried, which I mentioned, old biocontrols, this is a newer idea about biocontrols, is this handsome little fella, the milfoil weevil. And these exist in most lakes where there is invasive milfoil and they're naturally occurring. So the process is really to collect those from the lake and then rear them on land in sufficient numbers and then reinsert them into the milfoil bed. Now the issue, they're very effective. They actually eat the stem of the plant and cause the plant to die off. But the issue is that once they consume all their food, then the milfoil the weevils die off, and then the milfoil grows back, and it's very expensive to rear these. There is a company with a proprietary method in the States, but I believe they charge about $1.60 per weevil, and you have to release them in the hundreds of thousands, even in a small milfoil bed, to make them effective. So we did look at potentially rearing them here in a facility which is currently used to rear sterile insects for our fruit trees. And one of the problems is it's really hard to keep milfoil growing in a in a fish tank or in a lab, and so it wasn't really viable for us to do that. There are also new chemical controls. A lot of them are used in the States, and if anyone's familiar with the Osoyoos Lake, it's actually a boundary water. So the north half of the lake is in BC and the south half is in Washington. And in the States, they don't like the idea of rototilling their lake bottom, so they use aquatic herbicides in the southern half of Osoyoos Lake, and we use rototilling in the northern half. So they still do use 2,4-D, but it's not very effective because the plants are actually becoming resistant. There's another formulation called triclopyr, which is more selective, and the delivery method is now kind of almost a fish flake that floats down, lands on the plant, and then is properly absorbed. So that's been improved. There's a new one called fluoridone, which is under the name C-Pro's Sonar Aquatic Herbicide, and Procelicor, which apparently looks very promising, has a lower toxicity, there's less worker risk, it's more selective, and it has a shorter half-life. And these two gentlemen at the bottom are in the process of trying to get it listed by our federal government as a potentially approved aquatic herbicide. Still, there's no social license, and I can't see it being used anytime in the near future in the Okanagan. And then I found this one was really interesting. I got back into some of the old files from the province and from the OBWB. And in 1986, a couple of provincial employees were actually looking at using high intensity ultrasound. And they had found a transducer that was showing really good results in the lab for disrupting the cell membranes and causing the plant to die. I should say ultrasound has also been studied to control water chestnut and is also used in commercial applications to control algae blooms. So it's a potential, there is a potential there that this could be a new method of control. And I've actually recently engaged with UBC here in the Okanagan to maybe do some more research on this. So finally, I'm going to talk a little bit about what's the cost of the program. And this is a before photo, and this is the shoreline of Kelowna in about the 1970s or maybe the early 1980s. And this photo, this aerial photo, really shows well what the foreshore would look like without milfoil control. And of course, I did mention the sewage, which has largely been cleaned up now, partially from another OBWB grant program. Because there was a lot of nutrients in this water. So you can see all the dark areas, which are the milfoil, is the milfoil in the water. And then these areas where it's emerged from the top of the water and created algae blooms on the surface. And so I'll flip back and forth a couple times here because that's back then. And this is what that same area looked like in 2012. So this is after decades of rototilling, making sure those plants can't establish. You can see a few areas still where we might have missed for a year. And in the really near shore areas where the rototiller can't reach, near people's docks where it's just too shallow, especially in the winter, the lake draws down quite a bit in the winter. So the milfoil in here could have been in a little bit of water over the winter, and then it raises back up and it's right on people's kind of prime swimming area. So again, before and after. And so before I get into the costs of the program, I just want you to imagine what the Okanagan would look like to tourists and to residents if our lake was like this with uncontrolled milfoil everywhere. So the annual cost of the milfoil program in 2019 was $697,000. In 2020, it was reduced to $665,000, and that includes operational costs, salary, and equipment reserve. It's fairly stable. Some years we have, more maintenance costs than others, and so that's kind of the discrepancy. It has been as high as about $850,000 in years that we have to make equipment purchases. So I mentioned earlier, $92 billion in property value in the Okanagan, and the cost of the milfoil control program is 90 cents per $100,000 in property value. The average home in Kelowna is about $700,000 and means that the average property owner pays about $6.30 for the entire milfoil program covering the entire Okanagan Valley. and the average lakefront homeowner pays about $20 a year, again, to have a lot of the time their beaches cleaned. For that price is not bad. And finally, I mentioned that in the old days, there weren't even cabs on the machine. So I wanted to show what a sexy job this could have been. You could work on the water all day, middle of the winter on a frozen lake, covered by a sheet of plywood held up by 2x4s. But you'd have to be a really eager beaver to want to control milfoil. Like this guy. This is a photo my boss actually took 2 or 3 years ago, and it's just on the shoreline. And we're talking about biocontrol. It'd be interesting if we could rear a whole herd of beavers or a flotilla of beavers to control the milfoil, but I don't think that they're particularly selective to milfoil. And I anticipated taking longer, but that's actually the end of the slideshow, so I'm happy to take any questions.
Great, thanks so much for the presentation. I think, Jenna, we just have the one comment in the Q&A.
Yeah, we do. Somebody was just impressed with the outcomes.
Yeah, it's really impressive. I've only been here for about 8 years, but our operator who just retired a couple of years ago was here for 30 years. And he described walking out on Kin Beach, which is in the North Okanagan near the city of Vernon, in the 1980s, and you just sank up to your waist in muck, and it was basically a false bottom. And after multiple years of rototilling it, it creates oxygen, first of all, which allows a lot of that organic matter to be digested. And now it's a beautiful sandy bottom, which is more akin to what we would have expected it to be like before kind of humans came and started dumping sewage in and milfoil was introduced and those sorts of things.
Do you have any examples of systems in BC where there was an early detection of eurasian milfoil and where you've been able to control it or eradicate it, I should say?
Not that I know of. I did mention it's cyclical, so sometimes it does seem to go away in areas. There was a die-off in the south end of Osoyoos Lake a couple of years ago, and the folks in Washington weren't really sure why it died off. And so it's really one of the problems, and one of the things that I'm trying to address through my job now, is that there really hasn't been a lot of science done on milfoil since the 70s, because a lot of the research in the States has just focused on chemicals. And so they haven't really looked at any other type of control. And the plant, I would say, isn't even really that well understood. Its effects on habitat are understood, but mostly anecdotal. And so I think there's a lot of research that could happen because people have just focused on controlling it and not really understanding it that much.
Thanks for that. We've got questions rolling in now. So the first one here is, what long-term cost is there to the ecosystem from all the water milfoil removal? Does milfoil presence form a larger ecological cost?
Yeah, I'm not sure I'm clear on the question. I would say in the summertime, because we remove the biomass, that's when it would have the primary effect on the ecosystem. If it was allowed to grow and form those dense mats like I showed on the north end of Osoyoos Lake or in Vaso Lake. So I talked about the fish kills and the increased algae blooms, the changes in the water chemistry. It actually encourages waterfowl to come to these blooms, and then they defecate in large numbers in the water, and so it can cause spikes in E. coli and things like that. From a fish perspective, it actually favors invasive fish like the carp, and we have smallmouth and largemouth bass in the South Okanagan, and they'll sit there in the milfoil, in the thick milfoil beds, and basically hide in them. And then when the native salmonids like the trout and the different species of salmon are small, the juveniles float by, then the invasives will just pick them off. And so I know the Okanagan Nation Alliance has spent years and millions of dollars trying to reestablish a fishery here, and they've been quite successful. But milfoil is certainly not helping in that. So it is a big ecological cost. If it was uncontrolled, it would be completely different.
Thanks for that. Do you see major differences in Osoyoos Lake outcomes in the US versus Canada side?
I'm not as familiar with what happens in the US, but I do believe we generally have larger blooms in the Canadian side. But they don't always treat all the milfoil in Osoyoos Lake. They tend to treat it with, on private property, we focus a little more on public beaches. And then the area I showed in the north end of Osoyoos Lake is really not a huge priority for us compared to the public beaches and the commercial areas and things like that. And I'm not sure what their kind of range of priorities is like in Washington. But they also have other types of invasives that they also treat with chemicals down there.
Thank you. Note here, great presentation. Does BC have any programs for management of non-invasive aquatic plants, even in selective areas?
Not that I'm aware of. I know that a lot of them would be considered sensitive or protected. You have to apply, anytime you want to do any work in the water, you have to apply for a permit from the province. And so the only time I would think that they would allow any disturbance of native plants is if you were doing a development or water intake or things like that. It would be an exception rather than a program that allows you to continually remove it. Just as an example, there are a few bays here in the Okanagan where there are large like lily pad patches. And there's also some milfoil, and we're allowed to rototill the milfoil around the lily pads, but we're not allowed to touch the lily pads.
Perfect. What is done with the harvested milfoil?
Yeah, so we actually truck it away, and our first option is to always take it to people for compost for orchards and gardens and things like that. And then if we can't find someone to take a truckload of milfoil, we will end up taking it to the landfill. But I'd say 90% of what we remove from the lakes goes to either community gardens or orchards or people's private compost. And it does actually have like a low grade but commercial type of fertilizing component to it because it takes the phosphorus and nitrogen out of the water.
Thank you. So you mentioned the annual cost of the program, but how much did the machine actually cost to purchase? Yeah, so
this is a little rough numbers, but the rototiller that we bought most recently was about $350,000. That was one of our, I mean, it's still a large rototiller, but it's not our largest, so it probably reaches down 15 to 20 feet, not 25 feet. And then one of the harvesters, depending on the size, you can start with a harvester that has a 5-foot cutting deck for about $50,000 Canadian, and you can go up right to a 10 or 11-foot cutting deck for $200,000 Canadian. And then obviously there's the trucks and the cranes and the trailers and other equipment that go along with it.
Thank you. And we've got a couple here, and so we might call on Brad and others to help answer, but gotten a few questions about if there are any similar programs that you're aware of that are in Alberta that are similar to yours.
I don't know of any in Alberta. I know of several in BC, but I will say for the rototilling component, the Okanagan and Shuswap in Canada are the only, actually maybe in the world, are the only two jurisdictions that use rototilling. And that's also why the cost of the machines is so much, because they are a completely custom made machine. Whereas the harvesters are quite common for different types of aquatic plants throughout the world. And so there are, you know, off the top of my head, 5 or 6 different companies that manufacture them.
I'll just mention too, which was just briefly mentioned at the start of the presentation, but Alberta, as far as we know, does not have the invasive Eurasian milfoil in our lakes. And we're doing a lot of work to look for it and to try and keep it out of the province. So as of now, we don't necessarily need this program to remove milfoil because we're not faced with the same problem. I hope that answers that question. And there was one question about if this will be available online, and yes, this will be recorded and posted online next week. Just a question for you about spread of Eurasian milfoil, and can you maybe mention what the province is doing in BC to limit spread between lake systems, or even, you know, trying to keep it out of neighboring provinces or states?
Yeah, as far as targeting milfoil specifically, I'd say there's no action being taken. However, more broadly, we're encouraging clean, drain, dry, and as I'm sure everyone's familiar with the threat of invasive zebra and quagga mussels, there's a major push in BC to have people clean, drain, and dry their vessels between water bodies. And so if people were to follow that behavior, it would also stop the spread of milfoil. And then while I'm talking about mussels, I hope everyone's heard about invasive zebra and quagga mussels. And if not, I'd be happy to do another presentation at some point. But they're one of the species that would actually be symbiotic with milfoil. So they harm basically everything else in the lake, but because they're super filter feed the water, they clear it up and allow deeper light penetration, which allows the milfoil to grow even deeper and more densely. And then in some cases, the mussels will actually grow on the stems of the milfoil, which allows them to grow more densely and cover even more, more area, more surface area.
Perfect. And we have another question that just came in. So how much of the plant is needed to establish a new population in a lake, and how long is it viable out of water?
Again, there hasn't been a lot of science, so if I answer that, it would be pretty much purely conjecture. Unfortunately, I don't think a lot of plant is needed to establish, and I would say that the plant needs to be completely dried out if it's on the beach. Like, it would need to be above the high water mark and dry out completely. So probably 24 to 48 hours. I will say that those big piles of milfoil that we dump on the shore, they lose about 90% of their volume within about 3 days because they're drying out in the sun. And so they're very, very heavy and dense when we dump them there. And then within a few days, it's more like raking leaves on the beach.
Thank you. It looks like some of the other ones are coming in are a little bit more of an Alberta context, so I don't think we want to go through those ones.
We can just mention that there's a question regarding harvesting of other plants in Alberta, and I do know of at least one lake that has a harvester that is used to control native weeds down at Chestermere Lake. So I think maybe that's a question we can follow up with Alberta Environment and Parks for you to get a more specific answer about that. Someone did ask if it would be if your techniques would be useful for something like flowering rush. Do you guys have flowering rush in BC?
I believe we do in some places. The machine might need to be modified, like the harvesting machine might need to be modified. One of the problems we run into with some of our native weeds is that the stem makeup is a little bit different and it ends up being a little stringy. And so if we go through native weeds, and I can't remember the specific type, with our current harvester and those cutting teeth, they don't actually cut it off, they get tangled in the front of the machine. And so I could see needing to kind of re-engineer the blades or something like that. But there's lots of photos on Google from the States where they've used these machines and similar machines for even things like trash collection in the water, but where they use them for all sorts of different types of plants, including like, it's not lily pads, but it's similar styles of plants down in the southern states that end up clogging up entire navigation channels. And they'll just go through and take large swaths of the plants right out.
Oh, maybe one. Oh, okay. Someone just said thanks. A very interesting presentation. I'm curious, when someone reports milfoil in front of their property, what process do you go through to ensure that it's actually the invasive variety? Before we started broadcasting, you had mentioned that Eurasian milfoil actually hybridizes with the native northern milfoil.
Yeah, so we will try and send, first I'll ask for pictures usually, because that's a quick way in the digital age for me to identify whether it's milfoil or some other plant. But we will try and usually send one of our operators out to the area, preferably on a boat, so we can see not only the type of plant and the extent of the plant. We were mentioning in Washington, they've done some DNA tests that are now showing that the Eurasian and northern milfoil have began to hybridize. Without the DNA testing, it's really difficult to tell the difference between the two. And then just a little further context from a governance perspective, we have a formal policy that we prioritize public beaches and boat launches, areas requested by local governments before we will do the area adjacent to private land. And of course, all the water, all the area and even beach below the high water mark in BC is considered Crown land. So we don't do a pay for service. And if it's a new area where the homeowner is just worried about their own lakefront, or maybe a group of neighbors are worried about their own lakefront, but there's no real public use of that area, we will ask them to do the initial environmental permitting themselves, which could be a few $1,000s. But then if they are successful at getting the permitting, they can list us as the controlling agency, and we'll do it every year after that without any cost to the homeowner.
And I'll just mention for folks on the who are, well, obviously for people watching, that our organization just put out a new aquatic plant field guide, which does include a picture of Eurasian milfoil and northern milfoil. Jenna, from the province's side, if someone was to think that they found Eurasian milfoil in Alberta, would the hotline be the best number for them to report that to?
Yes. Yeah, if you report it to the hotline, then they'll send somebody out to assess.
Great. Are there any other questions in the chat or from anyone on the panel?
I got a question. Prior to the establishment of Eurasian milfoil in the Okanagan, were the littoral areas as clear as you're demonstrating they are now after treatment? Or were there other native plants that would grow vigorously in the Okanagan before Eurasian milfoil was introduced?
Yeah, there are certainly areas where there are other nearshore plants that would have grown fairly densely, but not to the same extent. And as I said, depending on where it is really, there are some areas that were just sandy beaches, and there are old black and white photographs with people having lawn parties on the lakefront, and we can identify those areas and we can see what the lake looked like back then. But also it won't grow everywhere. It won't grow in rocky substrate or specific, different types of substrate. So it is limited in its area. But also, like I mentioned, when we do rototill for a couple of years, particularly in those bays, we'll come back the next year, all the milfoil will basically be gone and native plants will have reestablished, and they'll be growing quite thickly and densely. And then you also see the native fish, and it just looks like a healthy aquatic environment again.
Great. Any other questions from anyone on the panel or from anyone viewing? Okay, I don't think so. So I want to say thanks again for the presentation. It's really interesting, and I think it's really important for us to learn from, a jurisdiction that's facing this as we try and just deal with the early detection and response phase of this invasive species. So I really appreciate your insight, and hopefully we don't have to follow up when we find Eurasian milfoil in one of our lakes here. And of course, thank you to our first presenter as well, Dr. Kristin Bianchini, a great presentation on loons. If anyone who's on the call now had missed that presentation at the start, you'll be able to check that out, the recorded version of that on our website next week. And just to mention, next week, we finished our webinar series with a final talk, or final two talks. The first one is on winter limnology and phytoplankton under the ice. And the second talk is on the groundwater and lake connection. So that will be next Friday at 10 o'clock till 12 o'clock. So I hope you'll all join us there. And thanks again to my fellow panelists, Jenna and Caleb. Okay, bye everybody.